Hello friends, in this video we are going to see what is goal stack planning. Goal stack is used to solve compound goals. Now in the previous video we had seen how strips representation represents different problems. Now this strips representation uh, operations can be given as input to goal stack. Goal stack is going to come up with the plan. Okay, so basically it's a two phase process. A problem is first converted into a strips representation wherein the initial state is specified, the goal state is specified, and different actions are specified with its preconditions, post conditions, and of course the delete list. Goal stack is basically used for coming up with a plan. So this input, which is nothing but the strips representation operators, can be given as input to the goal stack. Given an initial state and the final state, final goal to achieve, goal stack, it starts with the goal state. All the predicates which are there in the goal state are given as input to this goal stack. In fact, goal stack is initialized with the input as the predicates from the goal state. That's why it's called as a goal stack. And then with the series of steps that it takes, it ultimately comes up with a plan, sequence in which the operators can be applied to achieve the goal. So in this video, we are going to solve an example. We are going to take the help of block world problem and we are going to see how goal stack actually works. So as I've already told you, goal stack contains both the goals and the operators that have been proposed to satisfy those goals. The problem solver also relies on the database and describes the current situation and the set of operators described in precondition, add list and delete list. So this means that as the goal state planning resumes, for every step, for every iteration, it purely depends, the algorithm purely depends on the current situation or on the current state. What is the current state like? And it also depends the contents which are added onto the stack and the contents which are removed from the stack. This is basically based on the precondition, add list and delete list described in the operators or the actions from the strips representation. To know more about it, let us start with the process of operation of goal stack. Initially, goal stack contains the goal state predicates. For example, suppose we are taking now the example of a block world problem. Suppose the required goal state in the problem is this. Okay, wherein there are three blocks, and the required goal state is such that block A should be present on block B, and block B in turn should be present on block D. Suppose this is the goal state that is required. Okay, so initially what we do is all the predicates from the goal state are added to the stack. Okay, so how do we add that? First, the entire axiom is added to the goal stack, right? Then each of these predicates individually are again added onto the stack. So initially on a comma b and on b comma d together is placed on the stack, and then separate out on a comma b and separate out on b comma d and add them individually. So this is how the initial goal stack would look like. Since initially the stack contains the goal conditions, that's why the name of the stack is called as goal stack. Okay, now for this particular example that we are going to solve, we are taking up an example from the block world problem. And as I told you, the input to this goal stack algorithm is basically the strips representation actions, right? So whatever that goes into the stack, whichever predicates or function or actions that go into the stack, those that come out of the stack, they are all now dependent on the operators or actions which are specified using the strips representation. Recollect that in strips representation, every action or operator can be represented with the three lists: precondition list, delete list, and add list. Precondition list contains all those predicates which should hold true for the action to take place. Add list contains all those predicates which are now true after the action is already executed. Whereas delete list contains all those predicates from the precondition list which are no longer true. And we had seen this, and accordingly we are taking reference of these stack, pickup, put down and unstack action from the same previous video. Okay, the same problem that we had discussed in the previous video. So we are taking the help of these actions. Assume that the current state that is given to you is this, wherein block A is residing on block B and block C is residing on block D. So this is my current state. I will also call it as current world. So this is my current world, how it looks like. Now from this current world, our aim is to go and get this goal, wherein A should be on top of B, but B also should be on top of D. So ultimately the goal state that is desired is on A comma B and on B comma D, right? Our current world or current state is this. So every time that I'm going to solve the problem, I'm going to take reference of the current state until it changes. And as I progress and suppose the current state changes, then from then onwards I'll be taking the reference of the changed current state. All this you will realize when I'm actually solving the problem now. Okay. For now, just remember that initially all the predicates from the goal state are added onto the goal stack. So first we will add on A comma B and on B comma D together, and then on A comma B and on B comma D individually. Whenever you are adding them individually, you can follow any order. Either you can place on B comma D first or on A comma B first and so on. Okay, so let's start. So as I told you, initially the goal stack contains on A comma B and on B comma D, and on B comma D and on A comma B individually. Now the algorithm is like this. First we check what is there on top of the stack. If on top of the stack there is a predicate, then we check whether this predicate holds true with respect to the current world. Is on A comma B true with respect to the current world? The current world is this. Is A residing on B? Yes, it is true. Now, if the topmost predicate is true with respect to the current world, then you have to simply discard it. You have to simply pop it so that the next topmost element will be on B comma D, right? So since on A comma B is true with respect to our current state, we will pop on A comma B out to reveal on B comma D as follows. Now again, algorithm is going to check what is there on top of the stack. Is it a predicate? Yes, it's on B comma D. Okay. Now again, it is going to refer the current world or the current state and check whether this predicate is true with respect to the current world. Now when you go back, is B residing on D? No. With respect to current world, B is not residing on D. As a result, on B comma D is false. So then what algorithm does? Algorithm checks out of the 4 actions that we just saw, which action if we take, its effect is going to make this particular predicate true. I'm repeating it. If the topmost predicate on the stack is not true with respect to the current world or current state, then we have to check the set of actions or operators which are defined, and find out of these actions which action or operators result. And result means add list contains on b comma d or on something comma something as one of the predicates. Okay, that means if that particular action is executed, then the result of that will make this thing true, right? So let us go back and check. So out of these four actions, which action has on predicate in the add list? Okay, on predicate. So let's come with the stack action. In the add list of stack action, add list means the outcome of the action. There is one predicate called as on x comma y. Okay, so this is a eligible action. Here there is no on predicate in the add list, so this is not eligible. Here also there is no on predicate, so this is also not eligible. And here also there is no on predicate, so this is also not eligible. That means it is only stack action that if executed, then it will make on something comma something true. Okay, so then what we do, we have to execute, we have to replace on b comma d, which is the topmost element of the stack right now, with stack b comma d, because only when we execute the action stack b comma d, then on b comma d will be true. So x will be replaced with b, y will be replaced with d. Why? Because you want on b comma d, so x should be b, y should be d. Okay, so as I have already told you, what we'll be doing is, okay, so on b comma d, this thing is not true, so the action stack b comma d, which we just saw, has add list, has a content of the add list as arm empty and on x comma y. So what we will do is, we will pop this on b comma d out, and we will push that action which is going to make this thing true, that is stack b comma d. Okay, so on b comma d is removed, and on place of on b comma d, the action that is going to make on b comma d true will be pushed. Fine. So I will just recapitulate what I said. Algorithm first checks what is there on top of the stack. If it is a predicate, then that predicate is compared with the current state. If the predicate holds true with respect to the current state, the predicate is straight away discarded or it is popped out to reveal the next predicate or next action. Okay. Now, if top of the stack contains a predicate, but this predicate is not true with respect to the current world, then you have to see the set of actions which are there and choose that action whose outcome or add list contains one of the predicate as on predicate or this particular predicate. So we just found out that stack action has in the add list something called as on x comma y. Now since we wanted on b comma d, we had to substitute x with b, y with d, which makes on b comma d true. So once we have found a suitable action, we can now successfully remove this on predicate out of the stack, and in its place the action that is going to make that predicate true is action that is going to make the predicate true is inserted or is pushed. So on place of on b comma d, we have pushed stack b comma d. Okay. Now further, algorithm checks what is top of the stack now. If the top of the stack is not a predicate but it is an action, now here stack is an action, right? Then what it does? So if top of the stack is an action, then we all know that any action cannot be directly executed. For the action to be executed, all its preconditions have to be true. Okay, so what it does, it finds out all the preconditions, okay, of stack action, and those preconditions are loaded on top of the stack b comma d. So when all those predicates will become true, only then stack b comma d will be executed. Fine. So whenever on top of the stack there is a operator or action, you go to the operator, you go to that particular action and see what are the preconditions which should be satisfied for this action to take place. So precondition for stack b comma d is clear d and holding b. So this clear d and holding b are added on top of the stack action. Okay, so next we will see, so clear d, holding b, and clear d and holding b together. Okay, the precondition for stack b comma d to be true was what? It was an axiom, that is clear d and holding b. So once that is inserted, then you have to insert these predicates individually in any order. You can insert clear d first, or you can insert holding b first. In this case here, I have inserted holding b first, and on top of that clear d I have inserted. So that is fine, right? Now so far this is our current state. It has not yet changed. This is our current state. So whatever decision that we are going to take will be always with respect to the current state. Fine. So I have told you three cases. For first case, what happens when the top of the stack is a action, top of a stack is a predicate. Okay, if it is true with respect to current world, directly pop it out. If it is not true with respect to current world, then find out which action when executed can make this true and replace this predicate with that action. Now if on top of the stack there is an action, then you have to load all the prerequisites or preconditions for that action to be executed on top of the stack. Okay, so far fine. Now after loading all the preconditions, the topmost element of the stack is again checked. Is it an action or is it a predicate? It's a predicate. So now check with respect to the current state to find out whether this particular predicate is true with respect to current state. Is D clear with respect to current state? No, C is residing on D. So since this is not true, okay, again we have to go back to the set of operators or actions and find out which is that operator or action which has in its add list one predicate, that is clear predicate. Okay, so slight animation problem, but it's correct. Fine. So clear D is not true, but if you go to that previous set of actions, you will find out that there is one action called as unstack. Okay, unstack action. In that unstack actions add list, there is one predicate called as clear. Okay, that means the result of that action unstack will make something clear. Okay, so since you want D clear, the question is, how do you get unstack C comma D? Okay, looking at the current state, it's a common sense. If I'm going to unstack C, the robotic arm is going to hold C, and only then D will be clear, and that's why here it is unstack C comma D. So when this unstack C comma D is executed on the current state, the robotic arm will be holding C, and then D will be clear, and this will be satisfied. So that's why this should be C, this should be D. Okay, so then to make this predicate true, we replace this with action unstack C comma D. Fine. So unstack C comma D. Now, but for this unstack C comma D to be true, all the preconditions of unstack C comma D should be true. Okay, so we load all the preconditions of unstack C comma D on top of this action. Okay. Now these are all the preconditions of unstack C comma D. Okay, the precondition is C should be on D and C should be clear and arm should be empty. Only then you can unstack C from D. Okay, so what are the looking at the current state itself, you can find out what is the precondition. Okay, the precondition is C should be on D. Okay, C should be clear and arm should be empty. Only then the arm can unstack C from top of D, and after executing that action D will be clear. Okay, so we have loaded all the preconditions for unstack action on top of the action called as unstack. Now again we check what is there on top of the stack. It's a predicate. Now is this predicate true with respect to the current state? Is C present on D? Yes. So you can simply pop it. Fine. Similarly, this is the same current state we have represented again. So this is true, no? On C comma D is true. Is C also clear? Is there anything on top of C? No. So is C clear? Yes. So second predicate is also true. Is arm empty? Yes, arm is empty. So that means all three predicates or the prerequisites or preconditions for unstack action to be taken, all three are true. Okay, that's why I have represented them in the red color. So that means when all the preconditions are true with respect to current state, what you have to do, you have to go on popping all the preconditions, all the predicates till the action is revealed. Okay, and then two things will happen. Whenever an action is eligible for execution, like in this case, since preconditions all have satisfied, unstack C comma D action can be taken now. So after deleting all the preconditions which are satisfied, okay, when unstack action is relieved, two things will happen. One, this unstack C comma D, okay, action will be executed so that the current state will change to a new state. Okay, so unstack C comma D, executing this particular topmost action means what? Two things will happen. One, unstack C comma D action will be taken so that the current state will change to some new state, and second, unstack C comma D will be added as the first step in the plan. Okay, so all these are true with respect to current state. So what will happen, since preconditions are satisfied, pop action is executed and unstack C comma D action takes place, hence the current world changes. So this current world after unstack C comma D is executed, how it will look? It will look like this. Okay, C was on top of D. After unstacking C from top of D, robotic arm is now holding C and D is clear. Right? So these are the preconditions that we were talking about. So this is that current state, new current state. And I said two things will happen. One, the current world will change, and second, this action unstack C comma D can be now added to the plan. Agreed? So these are the steps. Now further, from now onwards, the current world or current state will look like this. So we are going to henceforth refer to this as the new current state, and we are not going to refer to this. This is gone. Fine. Now, unstack C comma D is executed. So new the current world changes, and second, it is added to the plan. So after that happens, you can now delete or you can now pop unstack C comma D action from the stack. So when all these are popped out, next topmost element of the stack will be holding B. Right? And our new current state is this. Yes? Now again the algorithm is going to check what is the topmost element of the stack. It is a predicate. Okay. Now you check whether this predicate is true with respect to the current world. Is the robotic arm holding B? It is not. So this is not true with respect to the current world. So if not, then now find out of those four actions, stack, unstack, push, stack, unstack, put down and pick up. out of these 4 actions, which action has in its add list one of the predicate as holding. Okay. Now here unstack action, if you just go back and check unstack x comma y, this action has a predicate called as holding x in its add list, and also another action called as pickup also has in its add list holding predicate. Now please note, unstack action also has in its add list holding predicate. Pickup action also has in its add list holding predicate. Which action are you going to choose? You have to be wise enough. Okay. So now what happens is, one clue is available that what you want is holding B. But here there is only one parameter that is known. Okay. So that means unstack x comma y, you know what is x, that is B. Okay, but do you know what is y? Is the second parameter revealed here? No. So whenever I say unstack B from top of some block, which is that block is not specified. So here this is still in a question mark. Whereas you go to the second action, that is pick up B. Okay, this is very clear action, right? There is only one parameter specified here. Here also there is one parameter specified. So there is no question mark here. And that's why, although there are two actions that I could have chosen, I go for pickup B. Okay, so what it means is, since pickup B after executing will make holding B true, so I will remove holding B from the stack and I will replace holding B with pickup B. Understood? Next, but for this action to be true, all its preconditions should be satisfied. So the preconditions of pickup B are all loaded on top of the stack. Okay, the preconditions are, you can refer the actions. Preconditions of pickup B are, B should be on table, B should be clear, and arm should be empty. Only then you can pick up B. I have just referred to the set of actions. Just replace X with B and I have taken this, right? So first you have to load entire axiom and then each predicate separately in any order, right? So if pickup B action has to be executed, then all these preconditions have to be satisfied. Now, topmost element of the stack now is a predicate on table B. So now you compare this predicate with respect to the current world. Is B on table? Yes. That means this satisfies. So this can be removed from the stack to reveal the next predicate clear B. Correct? So on table B is satisfied. So I have shown that in red color. So you can remove it from the stack. Correct? After removing it from the stack, the next predicate, that will be the topmost element, that will be clear B. Clear B will be the next topmost element. Now again compare this with the current state. Is clear B true with respect to the current world? No, because A is there on top of B. That means clear B is not true. So now find out of those 4 actions, which action has in its add list one of the predicate as clear B. Okay, so you will notice that unstack A comma B action, if you take, then in its add list you will have a predicate called as clear B. Okay, even looking at this particular figure, it is very clear. Okay, how can you make B clear? You can make this B clear by definitely unstacking A from top of B. Looking at this, you can easily say that it is unstack A comma B. Correct? Fine. And that's why I replace unstack A comma B in place of clear B. But for this action to be true, all its preconditions should be satisfied. So the preconditions of unstack A comma B are loaded on top of the stack. So what is the precondition of unstack A comma B? for unstacking A comma B, the very first thing is that A should be on top of B. Second, A should be clear and the arm should be empty. Only then you can unstack, correct? So all these conditions are loaded, and then each predicate individually in this particular axiom is loaded in any order. Now on A comma B is the topmost element. So if the topmost element happens to be a predicate, then compare it with the current state and see whether it is true. Is on A comma B true? Is A present on B? Yes. So this can be removed from the stack. Then is A also clear? Is A clear? Is there anything on top of A? Yes. There is nothing on top of the stack. So that means the second thing is also true. A is clear. Yes. Okay. Third, so since on A comma B and clear A is satisfied, okay, they will be popped out of the stack. But when you come to the third one, is arm empty satisfied? No, because arm is holding C, right? Which means on A comma B and clear A, only these two predicates are true with respect to current world, and this is not true. So these two will be removed, popped from the stack. Okay, to reveal arm empty, that will be the next topmost element of the stack. Okay, now is arm empty true with respect to the current world? No. So which is that action when taken can make this thing true? Okay, now please note that to make arm empty there are two actions. Either you can put down this C on the table so that arm will be empty, or second, you can stack C on top of D. You can stack C on top of D so that arm becomes empty. Now both the actions, okay, are possible. There is no question mark like last time, right? Both the things are possible. So you can choose this one or this one. Anyone you can choose. Let us say I am choosing put down C. I am choosing put down C action, right? So what will happen now is arm empty will be replaced with put down C. Yes. Now for put down C to be executed, all the preconditions of put down C should be satisfied. So first I will load the preconditions of put down C on top of the stack. So precondition of the put down C, there is only one, that is hand should be holding C. Okay. Next, when the top of the stack is a predicate, you compare that with the current world. Okay, and check whether this is true with respect to current world. Is the hand robotic arm holding C? Yes. So that means precondition is satisfied. So since precondition is satisfied, you can pop it out of the stack to reveal the next action. Yes. Also, since now this put down action can be executed, okay, after removing holding C, which is a precondition which I just satisfied, after removing it, put down C will be the topmost element, right? And that means put down C can be now executed. Executing an action means two things. One, the changes will be made to the current world, okay, by executing this put down C action, and second, this put down C will be added as a second step in the plan. So after put down C is executed here, okay, the new current world will have C on the table and arm empty. You can see here C, which arm was holding, now it is on table and the arm is empty. This is new current state. And also this action is added to the plan. So first we already had unstack C comma D, and now I add put down C also to the plan. Fine. So after doing these two things, now I can successfully remove put down C from the stack, so that the next topmost element revealed is on A comma B, clear A and arm empty. Yes. Now we check whether this predicate is true with respect to the current world. Is A present on B? Yes. Is A clear? Yes. And is arm empty? Yes. That means the predicate is true. Now notice that this predicate is basically the precondition which should be true for unstack A comma B action to be executed. And now since this is true, It simply means that you can remove this and unstack a comma b action can be executed. Okay, so what we'll do is we will remove this precondition out of the stack because this is satisfied, and unstack a comma b will be executed and it will be added to the plan and the world will change. So unstack a comma b executing means the current world will change. Okay, so next what we will see is a, which is on top of the stack, will be unstacked by the robotic arm, so that the result will be robotic arm is holding A and B will be clear. So this is my new state. And after changing the system, after the world is changed based on this action execution, next the same action is also added as a third step to the plan along with the previous two actions. These two actions were already added, and now unstack a comma b is also added to the plan as a third step. Okay, and after these two things are done, unstack a comma b also can be successfully removed from the stack to reveal the next topmost element, that will be arm empty. So now onwards we will be considering this as a new current state, right? So arm empty is now the next topmost element of the stack, and this is that new current word. Now is arm empty true with respect to the new current state or current word? No. So now find out which is that action that will make arm empty true. Now arm empty can be made true just by looking at this figure by two things. Either you can put down A on the table, or you can stack A on top of either B, D and C. Okay, so either you can stack A on top of some block Y. The problem here is whether you are going to stack A on B, whether you are going to stack A on D, or whether you are going to stack A on C. You know the block is A, but you don't know the second block on which you are going to stack this block A, right? That's why this is written as Y. So either this action can be executed, or put down action is very simple. Put down means block A is put down on the table. Okay, so from these two actions, this still has question mark because we are not confirmed with what is this Y. It could be B, D and C. We'll have to just explore and find out then whether our decision was correct or wrong. So it is better that I go for put down action because this is more clearer compared to this. So we replace arm empty with put down A because it is very easy to execute. So arm empty next will be replaced with put down A. But for this put down A action to be true, all the preconditions should be satisfied. So preconditions of put down will be loaded onto the stack on top of put down. There is only one precondition, that is holding A. Now when predicate is there on top of the stack, compare this with the current world and see whether it is true with respect to current world. Is robotic arm holding A? Yes, so this is true. Now since this is true, two things will happen. This predicate will be removed from the stack, and put down A now can be executed. Again, executing put down A will do two things. One, put down will execute so that this new current world will change, right? And then this put down A will be added to the plan. So two things will happen. So after A is put down, the new changed world, new current state will look like this. Okay, and this put down A will be added as the next step in the plan along with the previous three actions. Here, fourth step will be put down A. So now onwards we are going to refer to this new current state, and this current state will be discarded. So after changing the current world and after adding the action to the plan, now put down can be successfully removed from the stack so as to reveal on table B, clear B and arm empty as the topmost element of the stack, which I am going to show you next. So this is my current world, and now this is the topmost element of the stack, which is a predicate. Is it true with respect to current world? Is B on table? Yes. Is B clear? Yes. Is arm empty? Yes. So all three conditions are true. So notice that this predicate is basically the precondition for pick action to be executed, which simply means that now this particular predicate will be removed, exam will be removed from the stack, and pickup action can be executed. Now executing pickup action will do two things. One, pickup action will be executed and the current world will change accordingly. And second, this pickup B will be added to the plan as the fifth step, and then pickup can be removed from the stack. So after pickup B is executed, you will see that robotic arm has picked up B. So this is my new current state. Henceforth, I'll be referring to this current state and not this state. Okay. And second, the world has changed. And second, pickup action is added to the plan as the fifth step along with the previous steps. Okay. So after removing this and after removing this action, the next topmost element of the stack will be clear D and holding B. And this is the current world. I've just redrawn it here. Again, the topmost element of the stack is a predicate. So now check whether this predicate is true with respect to the current world. Is D clear? Yes, there is nothing on top of D. Is the robotic arm holding B? Yes, this is true. That means the precondition for stack B comma D action to be executed is true. So this can be successfully removed and stack action can be executed. Now executing stack action will do two things. One, it will change the current world by stacking B on top of D. And second, stack B comma D itself will be added as the next step of the plan. And then stack B comma D can be removed from the stack. So after B is stacked on top of D, this is the new current world. Okay. And in the plan, stack B comma D is added as a sixth step. Right, and then this can be removed, this can be removed. So now next, on A comma B and on B comma D will be the topmost element of the stack. Yes, and the current world is like this. Now is on A comma B true? Is A present on B? No. But is on B comma D true? Is B present on D? Yes, true. Correct. So on A comma B is not true, but on B comma D is true. Okay. So to make this on A comma B true, which action are you going to execute? Looking at this, it is very clear that if you want A to be on top of B, okay, that can be done only when you stack A on top of B. Correct? So stack A comma B is replaced and its precondition is added. So this whole thing is replaced with stack A comma B. You understood why stack A comma B? Because block A can be placed on top of B only by the stack action, stacking A on top of B. Maybe right now stack A comma B action may not be executed. You cannot do it because arm is empty. But maybe after one or two steps, okay, then this action stack A comma D will be executed. Fine. So stack A comma B is replaced and its precondition is added. If you are getting confused with which action to be executed, then it is very simple. You go back and you go through those actions, those four actions, and just check the add list and see which actions add list contains stack on A comma B as one of the predicates. Okay, so that is obviously stack action only. Fine. If you're getting confused with this kind of visual thing, then you can better just go on checking add list every time. You will not get confused. Okay, let us continue. So on A comma B was creating problem, on B comma D was true. So on A comma B, what can make it true? Stack A comma B action can make on A comma B true. So this full thing is replaced with stack A comma B, right? But for stack A comma B to be true, all its preconditions have to be satisfied. So all the preconditions of stack A comma B are loaded on top of the stack. Now topmost action, topmost predicate here is a clear predicate, clear B. Is B clear? Yes. Okay. So this clear B, since it is true, it will be removed from the stack to reveal the next predicate, that is holding A as the topmost element of the stack. Now, Is the arm holding A? No, arm is not holding A. Now find out which is that predicate that can make this thing true. Looking at the figure itself, I can tell you that pick up A is going to make holding A true. Correct? So you replace holding A with pick up A, right? But pickup A itself cannot be directly executed. All the preconditions of pickup A should be satisfied. So these are all the preconditions of pickup A which are loaded on top of pickup action. So that means A should be clear, A should be on table, and arm should be empty. Only then you can pick up A, right? Now see the topmost element of the stack, it's a predicate. Compare it. Is A clear? Yes, A is clear. So this can be removed. Is A on table? Yes, A is directly on table. So this second thing is also true. Is arm empty? Yes, arm is empty. So this is also true. That means all the predicates are true. So this also is true. That means all this can be removed and pickup action can be now executed. Okay. Now pickup action execution means two things will happen. One, pickup action will be executed and the current world will change, and that pickup action will be added to the plan. And after doing these two things, then pickup can be removed from the stack to reveal the next topmost element, that is clear B and holding A. So pickup action is executed. So the current world changes. A is now picked up by the robotic arm, and pickup A is also added as the seventh step in the plan. Okay. Now the topmost element of the stack is clear B and holding A. You compare this with the current state. Is B clear? Yes. Is robotic arm holding A? Yes. So that means this precondition is also satisfied. So that means this can be removed and stack A comma B action can be now executed. So two things will happen. Stack A comma B is executed so that the current state is changed. New current state will come next, and stack A comma B will be added to the plan, and then it can be successfully removed from the stack. Okay. So this is my new current state, and stack A comma B is also added to the stack, so that, please note, the goal stack after removing this stack A comma B will turn empty. Goal stack turns empty, and that time we check the new current state. Is it not same as the goal state now? Yes, it is. Because in the goal state, it was desired that A should reside on B and then B also should reside on D. And exactly the same thing we have got. That means initially the difference between the initial state and goal state was much. And goal stack planning, what it has done, it has linearly started solving the problem, reducing the difference between current state and goal state slowly, and here it has converged, and finally goal state and current state have become same. That means I have reached the solution. Now what do we get at the end of all this procedure, big procedure? At the end of all this big procedure, we are getting two things. One, we are able to reach the final state, but most importantly, what we get, what is the output of the goal stack is that you get a plan. Okay. Now what is this plan? This plan, if you now sit and with pen and paper, and if you try, you start with the initial state which I had given you and follow these actions one after the other. Within once you execute each of this action in this particular sequence, you are going to reach from the initial state to the goal state in these 8 number of steps. Okay. So this is the plan. Plan is what? It is basically the sequence in which the actions can be executed so that from the initial state you can reach to the goal state. So goal stack planning algorithm at the end gives you that plan. Okay, where you have the steps to be executed, the sequence in which the rules can be executed so as to get the goal state. Okay, so this is all about goal stack planning, which is a linear planning. Okay, thank you.